All right, so applying some of those circle facts, we're going to first talk about the arc addition postulate. So the measure of an arc formed by two adjacent arcs, or arcs that are right next to each other, is the sum of the measure of the two arcs. So basically, like we were talking about last semester with segment addition postulate or angle addition postulate, we have part plus part equals whole. So the measure of arc WX, well, that's just this minor arc here. We know the central angle is 60 degrees. And remember, the measure of the arc, of the minor arc, equals the measure of the central angle. So the measure of arc WX is going to be 60 degrees. All right, next up, we've got measure of arc X to Z to V. So the order is important. I'm starting at X, I'm going to Z, and then I end up at V. All right, so we know XY, we know the measure of arc XY is 63 degrees. All right, now we've got those two arcs that we don't know. But what if I look at it like this? What if I look at this, just this green part? What do you notice about arc YZV? The measure of arc YZV. Well, that is a semicircle. So a semicircle is going to be 180 degrees. So the measure of this major arc, XZV, is going to be these two arcs added together. So that's going to be 243 degrees. All right? So part plus part equals whole. And the whole idea is that the measure of the central angle equals the measure of the minor arc. So those two are going to be equal. That might help you be able to figure out what some arc measures are or central angles. Like this central angle here, just keep talking about this problem. This central angle here is going to be 63 degrees. All right, and then we know WZ is a diameter, which cuts the circle in half. So I could figure out that this angle is going to be 180 minus 60 minus 63. So this is going to be 57 degrees. We've got vertical angles here, so this is going to be 57 degrees. So it can apply a lot of stuff we've talked about before to fill in the rest of a diagram. All right, all with that idea that the measure of the central arc equals the measure of the angle. Measure of the central angle. So moving on to circumference. How do I calculate circumference, which remember is the distance around the circle? Well, the circumference, we could either be 2 pi r, or 2 times the radius is the diameter. So we could do pi times diameter. Yes, I'm sure you're familiar with pi, 3.14159, blah, 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 blah. All right. Pi is the ratio of the circumference and the diameter. So pi is going to be showing up a lot when we're dealing with circles. So we've got these two formulas that we could use to talk about circumference. So find the circumference of a circle with a radius of 11 meters. So since I've got the radius, I'm going to use the formula that deals with radius. So C equals 2 pi r, but instead of my radius, I'm going to plug in 11. Then I can simplify. 2 times 11 is 22. So C equals 22 pi meters. Now, I could stop here, and I especially want to stop there because that is an exact answer. So if a quiz or a test asks you for an exact answer, pi needs to still be in your answer. So 22 pi, that's the exact answer. Now if I use, let's get my calculator out here. If I use my calculator for 22 and then pi is the second function on this caret, so 22 pi, do not use 3.14. All right, you've got a calculator, so you need to use the pi function, okay, or the pi button. 22 pi, that's going to be 69.115. if I round to the nearest thousandths meters. Okay, so 69.115 meters. This is the approximate answer because I used my calculator and I had to round my answer. All right, so make sure you're paying attention to whether your question's asking for an exact answer or an approximate answer. All right, so next up, problem B says find the radius and diameter of a circle with a circumference of 18. So in this one, I'm telling you that the circumference is 18. So we need to work backwards to find the radius and the diameter. So if I wanted to find the radius, I get C equals 2 pi r. Plug in what you know. We know the circumference is 18. So equals 2 pi r. So to solve this, I'm going to divide both sides by 2 pi. Now, be very careful when you plug this into your calculator. All right, the exact answer is 9 over pi equals r. Okay, so that's the exact answer. But the approximate answer, if I plug it in my calculator, I got to be very careful making sure you plug parentheses around 2 pi. Because I'm taking 18 divided by 2 pi. All right, so the radius is going to be 2.865 yards. All right, if I round that to the nearest thousandth. If I type 18 divided by 2 pi without parentheses, notice how that's 28.27. That is not the same answer. Because what order of operations is doing in your calculator if you forget your parentheses is it's taking 18 divided by 2 and then multiplying it by pi. All right, that's not what we wanted to do. We wanted to divide all of 18 by 2 pi. So make sure you got parentheses. All right, you could also, your calculator can plug it in as a fraction for you if you want to make sure that your answer looks like it is on your piece of paper. So my radius is 2.865 yards. Now, the diameter, all I got to do is multiply my radius by 2. So the diameter is going to be 5.73 yards because I got 5.7295. 5 is going to make 9 round up to 10, which is going to make that 2 round up to 3. Okay, so there's the radius and the diameter if I give you the circumference. All right, now these are the approximate answers. All right. So that's dealing with circumference. Last type of problem is dealing with area. How do I find the area of a circle? Now the area of the circle is going to be pi r squared. And I kind of give you this example over here. If I take a circle and I divide it into equal wedges and I unravel that circle, we're going to get a parallelogram here where the base is pi times r and the height is radius. So pi times r is going to be pi r squared. So the area of a circle is pi r squared. So find the indicated measure. Find the area of the face of the watch if the radius is 4.2. So here we've got the radius. So I can just plug it straight in. Area equals pi 4.2 squared. All right, so if I go over here, 4.2 squared, if I wanted an exact answer, I would get 17.64 pi centimeters squared. All right, so that's my exact answer. Now, all I need to do to find my approximate is multiply this by pi. So area is going to be about 55.418 centimeters squared. This is my approximate. So there's that. And then part B is saying find the diameter of the CD. It gives us the area. So we don't have an area formula to find diameter. But we have an area formula where we can work backwards and find the radius. And if we know the radius, we just need to multiply that by 2 to get the diameter. So we can still do this. We got area equals pi r squared Plug in 201 for the area equals pi r squared. So I'm going to divide it by pi. Divide everything by pi. So I get 201 divided by pi equals r squared. And then all I need to do, use that color already, square root of both sides. So my radius is going to be the square root of 201 divided by pi. So I go over to my calculator, square root of 201 divided by pi. And the radius is going to be 7.999. I round that to the nearest thousandths, so 7.999 centimeters, which means if I multiply this by 2, my diameter, if I multiply this by 2, is going to be 15.998. All right, so 15.998 centimeters. So the diameter is about 16 centimeters. All right, so that's kind of our introduction to circles. We got vocab, we've got the arc addition postulate, circumference, and area. So using everything that we talked about, try these you try now problems. We'll go over them in class. If you have any questions, make sure to let me know. Email, stop by office hours. Other than that, I'll see you when I see you. Be safe.